Hello students, welcome back to yet another lecture. In this lecture, we will cover a bird's eye view on soil science, a brief on soil science, what soil science is and what are the dimensions of soil science, right? If you ask an engineer or civil engineering student, then he will answer that, okay, this is the base material for building making. If you ask any geologist, he will answer that, okay, this is the pool of different minerals. Then if you ask for a hydrologist, then okay, soil is a storage house for the water. If you ask for any agriculturist, then we must think according to the plant growth, rhizosphere, ecology, and how it affects the plant growth. This is of course a base material for plant growth, and simultaneously this is providing the water and nutrient to the plants. If we say land and soil, what is the difference? Then land is the two-dimensional structure. When we are buying any plot or anything, then we say it land. The value of land, the value of soil, nobody is saying. Okay, so that is a two-dimensional structure. Soil is a three-dimensional structure. There is a length, width, and there is a soil profile. There is in depth. If we say effective root zone depth, what is it? It is the soil profile of up to what centimeter the root goes and it takes nutrient and water, all that. If you see the earth, then there is crust, mantle, and core. Inner portion is core, then comes mantle, then upper portion is crust, earth crust. If you look at soil profile, then how it develops. It has a rock layer, like different kinds of rock. From there, the parent material develops. Different types of rock, you know that there are igneous rock, sedimentary rock, then metamorphic rock. Then different types of parent materials develop from rock. Then parent materials, they get weather, and then different soil layer produced. If we see the upper layer, that is organic layer or O horizon, then mineral horizon, A horizon, then E horizon, then B horizon, then C horizon. These are the horizons, these are the layers, these are the layers of soil profile. The well developed soil, you can find all these horizons. Then the soil which is not well developed, which is recently formed, like inceptial or alluvial soils, there the horizon you will find that is not well formed. If we see soil as a broad, then we will find the 50% of the soil is solid, another 50% is empty. That 50% of solid, 45% that is mineral constituent, and 5% that is organic constituent. And from that 50% space, 25% is air, 25% is water. But in general perception, if you see that people will say, okay, in sandy soil the porosity is higher and in clay soil the porosity is lower, but that is not true. Yes, micropore proportion is higher in sandy soil, but micropore and total porosity, then the clay soil, it is higher because the surface area of clay is much more than sandy soil, right? When we see a soil, why we say it sandy soil, loamy soil, clay soil, like that? Due to their proportion of these three constituents, their proportion, they make them sandy soil or clay soil or loamy soil. If the sand fraction is like more than 80%, then we say it sandy soil. Or if the clay fraction is more than 40%, then we say it clay soil. Then the loamy soil, if there is suitable proportion of this sand, silt, and clay, so that is loamy soil. Then the textural triangle that is developed by USDA, US Department of Agriculture, that categorizes soil into 12 textural classification. Again, there is soil structure which affect the root penetration and water movement in and all that. So there are different structures also. There is the soil is granular, or that is massive, peaty soil, columnar soil, then blocky soil, granular soil like crumby soil. So these are the soils. The crumby soil is most suitable for agriculture purpose because there is porosity and the granules are like structures are well developed. Then peaty soil, that hinders the infiltration of water because the porosity and the hydraulic conductivity is very low. Then these physical properties, like these are basic properties, that the texture and the structure, these are the basic properties. Structure we can manipulate, but the texture we can hardly manipulate because the texture is almost constant for a soil according to its particle constituent. Then how do we measure the proportion of that particle? We measure that particle's proportion in lab condition in like mechanical analysis using Stokes law. That is another chapter we will cover later on. So from these physical properties we can have like heat conductivity, then soil temperature, then soil air, then soil temperature, how it affects the crop growth. Soil temperature basically the when the solar radiation it falls on the soil, what happens, there is conduction process happens. Conduction means the transfer of heat in solid medium. Then there is another heat transfer method like convection, that is in liquid and gas. Then another is without medium, the heat transfer is known as radiation, right? So these are the heat transfer methods. So what happens when solar radiation insolation occurs in soil, then it conducts that radiation towards the lower layer. The temperature increases in the soil. So there is optimum temperature for crop growth, the seed germination and crop growth, that should be maintained. So if the porosity is higher, then the conductivity of that temperature is lower, right? If the porosity and water content is higher, then the conductivity of that soil is lower. So there are mesothermic, cryothermic, and all that classification is there. Then if we say soil aeration, right? So there are three measurement on which we can assume that okay, the soil is well aerated or not. That is biological oxygen demand, that is the carbon dioxide or oxygen percentage. Then there is redox potential, right? So what is biological oxygen demand? So there in soil, we know soil is the source of infinite life, and they do respiration process. So for respiration, oxygen required. And what happen when there is depletion, there is poor aeration, then they deplete the oxygen, but there is not enough supply of oxygen. That demand, that gap is known as biological oxygen demand. How much the organisms they demanding the oxygen, right? So then there is oxygen diffusion rate. Another thing is the oxygen diffusion rate. What is the oxygen diffusion rate in the soil? If that oxygen diffusion rate it goes below 20 into 10 to the power minus 8, okay, when the oxygen demand of that soil, oxygen diffusion rate of that soil goes below 20 into 10 to the minus 8 gram per centimeter per minute, then that plant suffers, right? And that there is carbon dioxide and oxygen concentration, like in percentage, when the oxygen percentage is less than 10%, then the root growth and plant activity will hamper. So again, there is another thing, that is redox potential, that measures the submergence or the okay, there is redox potential again. What happens when the soil is submerged with water, then there is reduction occurs. There is no oxygen at that time, so that measures the redox potential. In submerged soil, that is negative, and in oxidized soil, that aerated soil, that is positive. So these are some of the aeration. Why aeration required? Aeration required for root respiration, right? When for respiration, oxygen is required, and aeration required for root respiration and proper growth. So we have that's why we go for tillage and manipulation of the soil, so that the soil can breathe properly, right? And if there is the soil have earthworms and different microorganisms, then the breathing process it enhances, so the root can breathe properly if the soil has more number of earthworms, right? So again, there is soil color. Soil color according to its development, that is pedochromic and lithochromic soils, like soil color, and according to the mineral composition, the soil has different colors, like black soil, that is vermiculite, then red soil, alphaceous, then there are different soils like glaze soils, they seems to be blue in color, then there is tourmaline, then all these things have they're due to their mineral composition and the climate also. So there are some pedochromic and lithochromic. Chroma means soil color. So there are hue, value, and chroma. That is the hue is the dominant color spectrum, then value is the lightness and darkness, then the purity, that is chroma. So there is, and again that moon cell color chart is there. There are 175 colors chips are there. So that is another thing. So these are all about soil color. Then what happens? Then soil water is there, right? what is the classification of the soil water? One is available water, another is unavailable water. If we say biological classification, then if we say physical classification, there is gravitational water, then capillary water, then hygroscopic water. What is gravitational water? That water that percolates to the ground, that hold in the soil micropore, that is known as capillary water, and that water that is in vapor form, that is hygroscopic water. So what is the plant available water? The range between field capacity and permanent wilting point, you know, that is plant available water. Okay, so what happens when we sow the seed, it imbibes water and it germinates, then the radicle emerges, then that root that absorbs the water through active absorption or passive absorption, either through transpiration pool or mainly through transpiration pool it uptake the water, and through xylem it uptake the water, right? So these are the like soil water. Then there are movement of soil water in the soil, like saturated movement, unsaturated movement are there. Then SPAC is there, soil plant atmosphere continuum is there, through which water balance occurs in soil. Then nutrients, there are 14 mineral nutrients. I remember 14 mineral nutrients, but if you are thinking 17 essential elements, then I'm not saying that. 17 including carbon, hydrogen, oxygen, what plant gets from atmosphere also. So there are 14 mineral nutrients, those are essential for plant growth. Those are plant offtake from ground, okay, soil. So according to their distribution in soil, their magnitude, there is deficient soil, then excess like toxic soil are there. So what happens when we do a submergence in the soil? What happens in submergence layer? There is poor aeration, as I have mentioned. Then there is phosphorus, manganese, iron. They will their availability will increase, because phosphorus, what happens when there is acidic soil and alkaline soil, when we go for submergence or there is burning of water, then what happens, the salinity and alkalinity, acidity and salinity, they goes towards neutrality, so availability of phosphorus increases. What happens to iron and manganese? They are more available in reduced form. Iron and manganese both are more available in reduced form. That's why in summer soil the availability of iron and manganese increases, right? And what happens to aluminum? Aluminum toxicity is there in acidic soil. So when we pond the water, then that is goes towards neutrality, and aluminum toxicity is also reduced. So these are all about summer soil. Then what happens? We have petrology and topology. If we study the soil with respect to its genesis, with respect to all that, then that is known as classification. Then that is known as petrology. And topology, what is topology? That is the relation of soil with respect to plant growth, right? Then what are the concepts we studied? Like soil physics, we studied soil weathering, right? How soil developed? We know that for 1 inch soil development there is thousands of years required. So how like soil weathering process happens? When that is physical weathering, that is chemical weathering, that is biological weathering also there. And weathering, that there are several steps like initial, juvenile, final, and virile. These are the steps of weathering. There are minerals according to the mineral composition of the soil. The weathering happens. There are minerals like gypsum, they weather very fast, but simultaneously at that moment the minerals like zircon, they are very slow to weather, like, right? So quartz, zircon, these are the very slow weathering minerals. So according to the mineral composition of the soil, weathering happens and soil profile development occurs. We have petrology and topology. If we study the soil with respect to its genesis, with respect to classification, then that is known as petrology. And topology, what is topology? That is the relation of soil with respect to plant growth. Then what are the concepts we studied? Like soil physics, we studied soil weathering. How soil developed? We know that for 1 inch soil development there is thousands of years required. Soil weathering process happens. When that is physical weathering, that is chemical weathering, that is biological weathering also there. And the steps like initial, juvenile, final, and virile, these are the steps of weathering. There are minerals according to the mineral composition of the soil. The weathering happens. There are minerals like gypsum, they weather very fast, but simultaneously at that moment the minerals like zircon, they are very slow to weather. So quartz, zircon, these are the very slow weathering minerals. So according to the mineral composition of the soil, weathering happens and soil profile development occurs. Then the chemical properties like CC, pH, nutrient availability are there. So what is CC and AC? Then cation exchange capacity and anion exchange capacity. According to soil composition, soil mineral composition, the cation exchange capacity varies. There are silicate and non-silicate clays mineral like 1:1 clay mineral like kaolinite, then 2:1 like montmorillonite and vermiculite, then 2:2 like chlorite. So these are the clay minerals. According to its composition, the CC varies, and if there is humus, if there is clay, then the CC is obviously higher. So there is nutrient dynamics in soil happens, like soil solution, soil clay complex, immobilization, mineralization things happen in soils by which the nutrient is available to plant. So there are different mechanisms also happening. There are certain mineral nutrients, they are readily available. The movement inside soil is higher, and some are fixed in soil like phosphorus and zinc. They are almost immobile in soil if the mineral is cationic like calcium, magnesium, sodium, then except zinc. These are less mobile in soil. Anionic like negative charge like chlorine, then sulfate, nitrate, these are readily mobile in soil. Why this happen? Because soil clay micelle, if you see, there is the negative charge is there. So whenever positive charge they find, they attach with those negative charge, so there is the mobility is less. In the other hand, if we see anionic charge ion that repel that micelle, that will leach down, that is prone to leaching, and that you can find readily mobile, right? And the exception is phosphorus and zinc. Those cation and anion, they are fixed in the soil and generally get it through diffusion. Yes, from diffusion I remember that plant whatever nutrient they take, that is through mass flow, either through mass flow or through like diffusion or through root interception. These are all about soil fertility, soil and soil biology. We have soil microflora and soil macroflora, then soil macroflora and macrofauna. As we know, there are millions of organisms reside in the soil. If we take 1 gram of soil, there are millions of soil microbes we find. What they do, they decompose the soil, they take part in that soil forming process, that is weathering. Again, they mineralize the soil nutrients so that it avails to the plant. Some nitrogen fixing bacteria, like they reside in the root and they do the symbiosis activity and they fix the atmospheric nitrogen. These are all about a basic broad idea of soil. If we look as a bird's eye view on soil, then we find there are soil water, soil air, soil solid. According to their composition, soil texture, soil structure is there. There is weathering process, how soil forms, weathering process we knew. Then there is soil water, soil air, soil fertility, how soil fertility like mineralization and immobilization occurs, how they get into the root of higher plant. There are soil biology, there are different organisms in soil that is covered in soil biology. And there is soil genesis, there are different soil orders, soil subgroup, group, soil, all these things are there. So all these things, they affect plant growth. This is how you can summarize when you think about soil, because if you cannot view the soil as a whole, then this is very much difficult for those who are preparing for physical science or soil science, NET and PhD or whatever you are preparing for. You have to look on the subject like this, like there, if we say porosity of the soil, mind should think like this, like 1 minus BD by PD, the formula. Then the porosity is micropore or macropore, that is based on the pore size, that is less than 0.06 mm, then that is micropore. Then more than good soil, we must say the micropore and macropore should be equal proportion, 1:1. Then from porosity, the redox potential, all this differs. So like that, if we say soil color, directly your mind should strike that okay, there are pedochromic, there are lithochromic, and how the soil color is notified, that is hue, value, chroma, then soil color chart chips are there. And for the parent materials, what like red soil white is red, black soil white is black, like that. Then there are problem soil also there. If we say acidic soil, saline soil, and alkaline soil are there. So what are the pH, what are the SAR value, what are the ESP value, excessive sodium percentage value, and all, how they affect the nutrient availability. If we say soil water, what is the gravitational water and like capillary water, there are hygroscopic water, how they avail to the plant, what is the SPAC. If we say soil organism, what are the organisms found and what are the orders, like the fungus, that is higher in biomass, the number is higher in bacteria, like bacteria are more number in soil. So all these things you have to like strike in the mind, and how nutrient availability happens, like mineralization, immobilization, how it happens. The CN ratio this is also more important, how CN ratio differs in different soil. These are the things you have to think when you are studying soil. What is soil pH? What is C? All these things. So think like this while you are reading, whenever you are reading. This is all about a brief of soil science. If you have any doubt, then you just ask me in the comment section. See you in the next lecture, guys. Thank you.